Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on dot plots and column graphs. So let's start by looking at the table. So you'll notice one column says eye color, one column says frequency. The frequency column means how many times something occurred. So in this case, we're talking about eye color. A frequency of 4 for blue eyes meant that 4 people have blue eyes, 6 people have brown eyes, 3 had green eyes, and 2 had hazel eyes. So down the bottom you'll see this weird symbol. This means sum, and F means frequency. So sum of frequency, we're talking about how many people there were in total. So 4 plus 6 plus 3 plus 2 is 15. So that means there were 15 people in total. So what we are going to do is display this information in both a dot plot and a column graph. So let's start with the column graph. So to make a column graph, we always have 2 axes like this. One axis, one line going up and down, vertical, the other one horizontal going left to right. So we always have an F on the vertical axis. F means frequency. So we're going to number this axis because it's talking about how many times something occurred. So on the horizontal axis go the different categories. So there are 4 categories here: blue, brown, green, and hazel. Just in case you're wondering, I think hazel means like greeny brown eyes. So what we do for each of these categories is draw a column or a bar, and the height of that bar depends on how many times that category occurred. So note, column graphs are also called bar graphs for that reason. So let's look at blue. It occurred 4 times. So there were 4 people with blue eyes. So what we do is we draw a bar up to the number 4 on the frequency axis. So this bar here says that blue eyes occurred 4 times. So we do the same for brown. So brown, though, occurred 6 times. So we're going to draw the bar up to the number 6, because that's its frequency. And then green, we go up to 3, and hazel to 2. So this is just a visual representation of the data. It's convenient because you can just look at this graph and you can see, oh yeah, brown was the most common color. You can see that, you know, it occurred about twice as much as green eyes did, about 3 times as much as hazel did. That's what the point of column graphs is, just to display data in a convenient way. So that's actually our column graph done. Now what we're going to do is draw a dot plot. So dot plots are essentially the same thing, but they only have one axis. So along the axis, I'm again going to write the categories. So instead of drawing bars, I do a dot for each time each one occurred. So for blue eyes, they occurred 4 times, so I'm going to draw 4 dots above blue. Similarly, brown occurred 6 times, so I'm going to draw 6 dots above brown. Green occurred 3 times, so I'm going to draw 3 dots above green. And of course, hazel occurred twice, so I put 2 dots there. And that's the dot plot done. You can see that column graphs and dot plots display the information in basically the same way. It's up to you to decide which one you think gives better information. Of course, we wouldn't want to use dot plots if the frequency was really high. If there were like 100 people with blue eyes, well, we wouldn't want to draw 100 dots. That'd take too long. But that's how you draw dot plots and column graphs. So another point I want to make is that this data that we've collected here is what we call qualitative or categorical. The way to tell that it's qualitative or categorical is by determining whether people would respond with words or numbers. So if I ask someone their eye color, they're not going to respond with a number like 45 or 69. That's just crazy. Can't have an eye color that's 45. So they would respond with a word like brown, blue. You can consider these as categories. So that's why this is qualitative or categorical. We're going to look in a second at the other type, which is numerical or quantitative, which is when people respond with a number. So to determine which type of data it is, you ask yourself, will people respond with a word or category or a number? If they respond with a word or category, like blue, brown, green, or hazel, it is qualitative or categorical data. Let's go ahead and look at an example of numerical data. So now we're going to look at data that is numerical or quantitative. So this is numerical or quantitative because if you ask them what did they get in the Google quiz, what score did they get, they'd respond with a number, not a category. So we're going to once again put this in a dot plot, and then we're going to put it in a histogram, which is very similar to a column graph. So remember, dot plots only have one axis. This time, because the data is numerical, I put arrows on either end of the line. Now, we don't need to start at 0 or 1. But even though there were no scores of 4, we do need to put it on our axis here. Okay, so there was one score of 3, so it gets 1 dot. There were no scores of 4, so I don't put anything in that column. And then 5, there was 1 score. And then there were 3 scores of 6, so that will get 3 dots. And I'm sure you get the idea now. And here our dot plot is done. So now what we're going to do is create a histogram, which as I said is very similar to a column graph. So we're going to set it up the same way with 2 axes. So because we have numerical data, I've numbered each axis. Once again, the vertical axis is frequency, and the horizontal axis is the scores. These time they're numbers. So I put an arrow on both axes because it's numerical data. So notice I have started at 0 and I have included all numbers, including 4, even though there were no scores of 4. So when we're drawing a histogram, we actually still draw bars. The higher the bar, the higher the frequency, but this time the bars touch. So for my first score of 3, I'm going to draw a bar up to 1 because it had a frequency of 1, and similarly for 5. Now for 6, there were 3 of them. So now the bars touch, and I go up to 3 like this. For 7, it's up to 1 again, and so on. It's like a column graph, except the bars or the columns touch. Now we use column graphs for non-numerical data, so for quantitative or categorical data like eye color, but we use histograms for numerical or quantitative data. So they look very similar. As I said, the only difference is that the bars touch for a histogram. So if we are using numerical data, we can calculate the mean, median, mode, and range. You can't calculate the mean eye color or the median eye color because it's not numerical data. But when we have data that scores from a Google quiz, because it's numerical, I can calculate the mean, median, mode, and range. And I'm going to show you how to do that using a dot plot. So let's look back at the dot plot over here. So the mode of the scores is really easy to calculate. It's just the one that occurs the most. So we can see 8 occurred the most. It has more dots, so the mode is 8. So we can see that the total number of dots here is 15. There are 15 scores. So if I want to calculate the median, there's going to be one middle score. So if there are 15 scores, the median's going to be the 8th score because there'll be 7 scores below it and 7 behind it. So counting from the smallest, I go 1, 2, 3, 4, 5, 6, 7, 8. The 8th score here is 8. And you can see there are 7 above it, so 2, 4, 7 above it. And there are also these 7 below it. Same number of scores below it and above it, so the median is also 8. So to calculate the mean, I need to add up the scores and divide by how many there are. So adding up the scores can actually be aided by the dot plot. Instead of going 3 plus 5 plus 6 plus 6 plus 6, we can do it a shortcut way. To calculate the mean, we have 3 plus 5. Now there are 3 6s, so I can just write that as 3 times 6 rather than 6 plus 6 plus 6. Then there's 1 7. And there are 4 8s. That's where the dot plot comes in handy. I can just go 4 times 8 rather than adding up 8 4 times. And then there are 2 9s and 2 10s. Adding up all of these scores gives me 113. So remember, for the mean, you have to take all the scores and divide by how many there are. So there are 15 scores here. So the mean is 7.53 recurring, we can just write it as 7.53 to 2 decimal places. So that's how the dot plot can make the mean calculation a little easier. So let's calculate the range of the scores. So I'm doing that in different color because remember, mean, median, and mode tell you about the center of the data, and the range tells you how spread out it is, as we learned last lesson. So the range, we can just see it's the largest minus the smallest, 10 minus 3, which is equal to 7. How easy is that? All right, now we're going to look at grouping data in a histogram. So let's look at this data here. So let's just say these are scores from a test. So the problem with trying to use a dot plot or histogram for this data is no score is repeated. So really a dot plot or column graph wouldn't help. All the bars would just go up to 1. But the other problem is there's quite a range of scores. The range is 41. The scores go from 59 to 100. Now we don't want to draw up our axis like this and then go, 59 and 60 and so on all the way up to 100. That'll take too long. And as I said, it won't display any useful information because each score that does occurs only once. What we're going to do is try a different approach. We're going to put this in a histogram, but it's going to be a bit different than the histograms we've been using. So we're going to draw up our axes like normal. So now, instead of doing each score individually, 59, 60, all the way up to 100, we're going to group them in groups of 10. We're going to put all the scores in the 50s together, all the scores in the 60s together, and so on. So this is what my horizontal axis will look like. So we don't need to start at 0 here for the histogram because there's no scores between 0 and 59. There's no point. So what we do is this bar here, we're going to draw a bar here between 50 and 60. That includes all the scores in the 50s. So there was only one of them, and that was 59. So we're going to draw this up to a frequency of 1. This bar is for the 60s. So there was 1, 2, and there were 3 scores in total in the 60s. So the next bar goes up to a frequency of 3. And then there were 2 scores in the 70s, so they go here. So note, in the 70s is the bar that comes just after 70s. And the bar that comes just after 80 are the scores in the 80s. So there was only one of those scores. And then you can see that there were 3 scores in the 90s, so we'll draw that bar up to 3. And then the score of 100 goes in the next bar. And there was only one of those. So that effectively is all the scores from 100 to 109 inclusive. So what you should do is count the frequency of your bars and make sure it's equal to the number of scores. So the frequency here was 1, then there was 3, 2, 1, 3, 1. Of course, these numbers add to 11, which was the number of scores we had originally. So we know we've done something right. Now, we usually don't write these numbers, the frequencies on the bar. I just wrote them there for a second so we could check that we had the right number of scores. So, of course, if I just give you this diagram down here, just give you the histogram, you can't calculate from that the mean, median, mode, or range. So just looking at this bar here, we can't tell whether the score is 50 or 51 or 53 or 59 or whatever. Similarly, we can't tell the scores in here. Are they all 90? Is one of them 95? The other two 92? Whatever. We don't actually know. You can't get that information. You can't get information about individual scores from a grouped histogram like this, so you can't calculate the mean, median, or mode. But it's just a more convenient way to display data when there are lots of different scores, the range is large, and the scores don't repeat themselves. Okay, thank you so much for watching this video. This has been the luckiest maths teacher in the world. Have a great day.